Let's look at the first example. 1/3 plus 1/4. Imagine two circles. One divided into three equal parts, the other into four. In the first circle, one out of three parts is shaded yellow. This is 1/3. And in the second, one out of four, this is 1/4. How do we add these fractions together? The pieces are different sizes, so we can't add them like we do with fractions that have the same denominator. What if we try to make the pieces the same size? Let's try cutting each piece in half. Maybe that will help. Unfortunately, no. Even after cutting, the pieces are still different sizes. We need a different approach. Some of you might ask, how does slicing the pieces affect the fractions? Let's look at the next animation. When we cut a piece in half, we double the number of pieces. That means 1 becomes 2 and 3 becomes 6. So cutting in half is the same as multiplying both the numerator and denominator by 2. That turns 1/3 into 2/6 and 1/4 into 2/8. If we had cut each piece into 3 parts, we'd be multiplying by 3, both top and bottom. Back to our example. How should we slice the circles? First, we find the least common multiple of 3 and 4. That's the smallest number that's divisible by 3 and 4 simultaneously. It's easy to see that the answer is 12. So after cutting, each circle should have 12 equal pieces. This will be the new common denominator of our fractions. To figure out how to cut the circles, we divide 12 by 3. We get a factor of 4. This means each part in the first circle should be divided into 4 parts. For the second circle, divide 12 by 4. We get 3. So each part there is divided into 3 parts. In fraction terms, this looks like multiplying the numerator and denominator of the first fraction by 4 and the second by 3. As a result, 1/3 becomes 4/12 and 1/4 becomes 3/12. Going back to our original problem, we now have 4/12 plus 3/12. Now the denominators are the same, and we know how to work with that. Keep the denominator and add the numerators. The answer is 7/12.